a clean room at the Space Test Center of IABG in Ottobrunn, Germany. For the past 50 years, this has been a place where satellites have been prepared and tested before they are sent into space. For LISA Pathfinder, today is the day it becomes a real satellite.
This is the first time that the real flight experiment and the flight spacecraft have been together, ever.
This is a milestone for the project. Tensions run high as just about everything on the mission has never been done the way it is done on LISA Pathfinder.
So the LISA Pathfinder spacecraft is unique. It's a bespoke design. It's a one-off. It's nothing like a telecommunications satellite where you might build quite a few of the same type of platform. It's been specifically designed for the purpose that it's going to be used for. So with the central cylinder for the instrument to go into, and obviously the kind of polygon type design so that we can actually get all of the different units in that we need.
LISA Pathfinder is relatively small. Despite this, the satellite has special navigation and propulsion systems which are designed to support the experiment.
The whole mission in the LISA Pathfinder is actually a technology demonstrator. The whole point is to show that the idea behind doing the real LISA mission could actually work. So that's not just with the instrument, that's also with the types of things that we've actually got on board.
It is not just the design of LISA Pathfinder which makes it so special. The experiment it will perform is also completely new. The satellite will actively support the running of the experiment once it reaches its destination. Once the experiment is running, the spacecraft will make sure the test masses remain in absolutely undisturbed free fall inside it.
Es waren extrem viele technische Herausforderungen da, weil wir an die Grenzen.
We had a lot of challenges, since we are pushing physics to the limit. We have worked with different universities, like Glasgow, where the optical bench was made. They have developed a method for bonding optical components, which allows us to direct the laser beam as we want to. We had to build a latching mechanism which is able to hold the two gold-platinum test masses securely during launch, but which can also release them to float freely in orbit. That cost us a lot of time and effort.
Das hat uns sehr viel Zeit, sehr viel Mühe gekostet.
After 10 years of research and construction, LISA Pathfinder's instrument is now complete. Hidden in the central cylinder is essentially a complete gravitational wave detector, just shrunk down to fit, an extremely sensitive laser interferometer with an optical bench and two test masses having their movements measured very precisely, but too small to measure gravitational waves. This masterpiece of optical engineering has already proven its robustness and functionality in a whole battery of tests, and it has been declared fit to go into space. Now it is time for a last briefing for the engineers and technicians, and then they will start installing the experiment into the flight spacecraft.
We had a dummy, or it was a flight spare, and a thermal model, which did have a part of the bench, the optical bench in it. That was put in a number of years ago when they came and did a previous test campaign, but it wasn't the actual real flight one. So this is the first time that the real one has been with the real spacecraft. So it's quite a big event. It's the beating heart of the machine finally gone in, the last big piece of the jigsaw puzzle.
The cylinders being lifted on a crane by the technicians from Germany who built the instrument. Then the unique and valuable piece of equipment is officially handed over to their British colleagues. The LISA Pathfinder experiment is being maneuvered into position millimeter by millimeter. There can be no mistakes now. Everything went as planned. Now the cylinder just needs to be released, bolted into place and connected.
Once those are in, we will perform a test, an electrical test, where we'll basically check that everything is communicating. And as soon as that's finished successfully, then we will all shake hands, and our colleagues will go back to Friedrichshafen having delivered their instruments, and we will prepare for the next test and to take it to launch.
The engineers and technicians from Friedrichshafen perform last checks to make sure that the instrument has been integrated successfully. Then it is time for the countdown to LISA Pathfinder's launch in autumn 2015.
We are really happy to have succeeded, and earlier than expected, even if it is only 4 weeks. We are enormously glad to see the experiment properly seated in the spacecraft body so it can be securely bolted down. Seeing the whole thing get to where we are now, that has been a great experience for me personally.